Hey, everybody, and welcome back to another episode of Adventures in Machine Learning. This week on our panel, we have Francois Bertrand.
Howdy.
We also have Ben Wilson.
Hello there.
I'm Charles Max Wood from devchat.tv. If my throat sounds scratchy, it's because the air quality here in Utah is awful right now. And I've been breathing in Utah, so that's the way that goes. We have a special guest this week, and that's Alexey Grigorev.
Hello.
Do you want to introduce yourself real quick, Alexey? Let people know who you are, why you're awesome.
Yeah. So I am awesome because, a number of things, I guess. A few words about me. So I work as a principal data scientist at Alexey Group. So Alexey Group is it's a company. It's an online marketplace. So it's a place where you go to sell things or buy used things. So I work there as a principal data scientist. A principal data scientist means that I don't code as much anymore. So I'm mostly doing a lot of meetings, a lot of alignment meetings. So the focus I have right now at Alexey is I'm helping data scientists be more effective. So they focus on data science and they don't worry about all this infrastructure stuff. So it's about like how do they go about deploying things? How do they go about what are the best tools for doing certain things? What are the best processes? Like how things should happen. So this is something I am helping with. I also have a hobby. This is called Data Talks Club, which is a community of people who love data. And there I'm like a sort of community manager, doing pretty much everything from, everything that you can imagine, because I'm the only one who is running that thing. Yeah, and this is a cool place. So we have Slack, we have podcast, we have YouTube channel. And yeah, it's a great place. Check it out.
That sounds like fun.
Did you work your tail off to get that senior developer gig just to realize that senior dev doesn't actually mean dream job? I've been there too. My first senior developer job was at a place where all of our triumphs were the bosses and all the failures were ours. The second one was a great place to continue to learn and grow, only for it to go under due to poor management. And now I get job offers from great places to work all the time. Not only that, but the last job interview I actually sat in was a discussion about how much my podcast had helped the people interviewing me. If you're looking for a way to get into your dream job, then join our Dev Heroes Accelerator. Not only will we help you get the kind of exposure that makes you attractive to your dream employer, but you'll be able to ask them for top dollar as well. Check it out at devheroesaccelerator.com.
Yeah, and you said that you have a video on from software engineer to machine learning. And yeah, I know that we get asked about that. Ben said that he gets asked for it. You said it's a pretty popular video. So why don't we just dive into that and talk about how people can make that transition? You know, if you're writing code for a living, you're thinking, oh, this looks like an interesting place for me to go and apply my trade in a different way. Yeah, what does that transition look like?
Yeah, so I can tell you how it looked like for me. So my original background is databases. So I learned at university. So I learned how to program. I learned how to design databases. And then my first job was it was in Java. So I was doing usual software engineering stuff. And then I worked at a bank, working again a lot with databases, with Java, with Oracle, all this kind of stuff. And then I watched this Coursera course about machine learning. And this is what got me excited. It was quite a while ago. It was 2012, 2013.
Mm-hmm.
So maybe not like now there are more modern, maybe I would say, courses, but this is what got me excited. So that course and then a bunch of other things. So then I tried to get in data science and machine learning with just that. So with my experience in Java and with the bits that I picked up during courses. Back then, it wasn't enough. Like it wasn't enough. People would say, hey, you don't have a PhD. Everything in our team has a PhD in mathematics or physics. So go get a PhD and then come back and we'll talk, right? Things like that don't happen anymore these days, right? So people are not attached to, like they don't care if you have a degree or not. Like they only care if you can do the things. It wasn't the case back then when I was transitioning. So I decided to go to do a master's first.
Just a real quick thing on what you just said. That's interesting to me because I'm more into, my main field is video games, and I do data visualization, which is just on the one aspect of machine learning. But that's very surprising because I would have thought that as the field matures, you need more formal credentials. And before, I would have I would have thought it might have been flipped, right? Back in the day, if you could show something great, then, oh, that's great. This is a new thing. We need, a crack at this. And then, but, now that it's more formal, they're looking at, formal credentials. But it's interesting how that's kind of the opposite.
Yeah. Maybe my opinion. So the way I think about this is, so back then, people had no idea what they want. So they just, okay, data science is about math and formulas. So maybe we need to get somebody who is good about that, right? But now these days, people know concretely, like they know what they want, and they know that machine learning is a lot about coding. So it's a lot about programming. And now people have experience doing these things, putting these things to production. They know what is important for the job and what is not. So now they know that having a PhD is not like, it's a good signal, but it's not a must. Like it's not a deciding factor when you're thinking whether you should hire somebody or not. But the important
I have an example of this. There was a few years ago, there was a company, huge company. They decided that they were going to use Ruby on Rails. And so they put up the job rec and they said they wanted 10 years of Ruby on Rails. Well, it turned out there was only one person in the whole world that had 10 years of Ruby on Rails. It was the guy that created it. And they called him up and they said, looks like you have 10 years of Ruby on Rails. And he laughed in their face. And then he outed them in a talk at RailsConf. So anyway, they do make those requirements and they do make them ignorantly. But for lack of anything else, they do it.
Yeah, back in the day with data science work, it was almost required that you needed somebody with that background, though. There weren't high-level APIs that were readily available. You go back 12, 15 years ago, everybody was called something different than a data scientist. That coin
data
term
mining.
Came along. Yeah, it'd be like you're a statistician or you're working in just the analytics department, but they would be, those people back then that were called that would be called data scientists today. And sometimes it was novel algorithm development. So if you don't have that foundation in math or in physics to be able to craft that, and the computing systems that some of this stuff was running on for the production ML back in the day required a hybrid team of software developers and statisticians and pure math people. But nowadays anybody can kind of learn it, which is kind of cool. So the requirements are laxed, except for some industries which still require that.
Yeah, so I was like, you're right, Ben. So like if we talk about pioneers in data science, like they really needed to do this cutting edge stuff, right? So they really needed to have people who have PhDs, right? To be able to do that. But
I'm talking about be able to invent the pieces that didn't exist
exactly. Yet. But I'm talking about usual companies who just heard that back then it became sort of like it maybe started this hype cycle, like this data science and machine learning. Maybe also because of Andrew Ng's course. I don't know. But they just heard, okay, this is something cool, but we have no idea who we need to hire. And we heard that, there are math and formulas. So let's get a bunch of people with PhD, just throw some money at them and let them do some magic. And then a few years after that, it turned out that it doesn't work like that. You can throw money on them, but like it's not enough to just get a bunch of smart people and some budget. You also need to have some engineers, right? You also need to have business people. Like they shouldn't work in isolation. They shouldn't be just sitting in their room doing research. They should be connected to the company. All these things now we understand, but I don't know. 10 years ago, it wasn't clear, right? And I think I got lucky that when I graduated, when I did my master's, when I finished my master's, people realized that usual small companies, like not Googles and Facebooks, but small companies in Berlin, I'm based in Berlin, they realized that what is important, what is more important, and maybe these credentials are less important. And then I'm talking around now, I graduated in 2015. So it was a lot easier to get into data science, with just a good portfolio, right? And maybe actually my recommendation for those who are interested in making the switch now. So all you need to do, or maybe like it sounds like it's not too much, but it's maybe difficult. All you need to do is have a good portfolio. Like it takes time to build a portfolio, right? But I think this is what you should have, right? A good portfolio. Doesn't matter if you got this portfolio like from university or from doing freelance projects, or it's just your pet projects, or this is something you do at work. But if you have I would quote air quotes, solid record of applying machine learning, it can be through pet projects or it doesn't matter. If you can talk about your projects, if you can say, okay, I did this, and this because reasons, then it improves your chances of getting hired, even though maybe you don't have any formal background at all. Yeah. So maybe to answer your original question, how would software engineers transition to machine learning? So for me, it was I needed to go through formal training, but I think it's less important now. And the more important is that you can demonstrate that you can actually do this thing, right? And so now for transitioning, I would focus effort on that, not picking up a ton of textbooks in the library and then digging through them and memorizing all these formulas, but actually doing hands-on stuff.
I'm assuming, I haven't looked for a job recently in the data science, but are there barrier requirements that you shouldn't be afraid of circumventing, like saying, oh, we're trying to hire this guy, for this position, and we need a bachelor's degree or whatever, these kinds of things. Are these, no roadblocks? Should you still go for it?
So the way I think about this is when you write a job description, you have an ideal person in mind, right? Somebody who is somebody who checks all the boxes, right? It's they're the ideal candidate. And the way I think about this is this ideal candidate often doesn't exist, right? So the ideal candidate knows all the math, right? So not just basic classical machine learning, but also maybe an expert in deep learning. They know not just
they're thinking of me, but there's only one of me.
Yeah. So basically, if it's just you, then you're probably employed now. And yes, where are they going to get the next you? Well, they have to lower the requirements, right? So maybe not all the boxes are ticked, but maybe some of them. And so I'm thinking about when I think about this, I just treat this as everything is non-essential. If you tick at least some of the boxes, it's already good, and you just apply, right? And then because there is a big shortage of candidates, anyways, there's high chances that maybe the company, if they've been hiring for some time, they saw the candidates, most of them weren't qualified, and if now you show up and say, hey, I actually know how to import scikit-learn, and I know what is cross-validation, what's the difference between, training and validation set, and I also know how to import XGBoost. That's maybe 19th percentile already. So yeah,
some of those job requirements I always find them kind of funny when I see contacted via LinkedIn or personal email all the time, hey, we have this position and here's the requirements. And then I look up the company and I look at the requirements and I look at it again and think about what the job is. And I just sort of chuckle to myself. I gracefully decline their invitation, but it's amusing to me thinking that they would think that they would be able to afford somebody that could actually check all those boxes. And some of the times it's a small startup. There's maybe 30 or 40 people working there. You have the same requirements that Google and Facebook do for their ML engineering team. It's there's no way you're going to compete with them. So yeah, no company is actually looking for that candidate. And if they do get that candidate and they can afford them, you should be suspect of that candidate. What are they running away from that they would accept this job offer if they do all that stuff?
You mentioned portfolio pieces. It's funny how that's very similar again to video games, where for 15 years I've been telling people, the best thing to get a job is just do your own project and have something that's great. Also focusing, it's better to have one great thing than 10 mediocre ones. I'm not sure
that's
how
all the same for web too, by the way.
Yeah, it's so I wonder how does that translate to ML, because it's not as flashy probably as web and video game developments, but as a pet project, if you're starting out, you probably don't have a whole list of clients you can point to.
If you think about this, yes, one big project is better than 10 mediocre ones. But I would say that 10 mediocre ones, or I wouldn't use the word mediocre, but maybe 10, just 10 project doesn't mean that maybe 10 small projects is better than no projects, right? And most of people who are trying to transition right now, they took some courses, they maybe bought a couple of books, theoretical books like deep learning and elements of statistical learning. These are good books. They're excellent books if we're talking about theory. And so maybe some of them also work through some of the books, solve the exercises, and the portfolio they have is that, right? So they read the books and they know how to derive all these formulas. This is cool. This is very interesting. And I really enjoyed doing this during masters, but none of the employers care about this. Oh, unless maybe it's DeepMind or something. But like if you talk about an average company in an industry, they don't care about all these formulas. All they care about these projects. And so I mentioned that 10 small projects is better than all that, because you can just take something small, like, I don't know, go to Kaggle, find a competition there, do this competition, and you already have one project in your portfolio. It doesn't have to be a great project. You don't have to score like to end in gold with a gold medal. Even if you end up in, I don't know, top 30%, which is like, on position number 300, it doesn't really matter. What matters is what you learned while doing this, right? And if you can, if you can explain what the problem is, what kind of data set it is, what kind of feature engineering you did, why you use this model. And the most important part in Kaggle is how you set up all these cross-validation things. I think this is already great. And if you do this for a couple of projects, like for 3, for 4, for different ones. So let's say take one where it's, a regression problem, then take another that is a classification problem, then take another that has maybe some natural text in English or in some other, maybe take another that has some images there. And you have 4 different projects that that look quite great on your portfolio. And already, like, you can already relate to, like, let's say if you have an interview and they ask you a certain question, then you can think, okay, wait a minute, it's very similar to that competition on Kaggle I did. And you can start talking about this, and then you basically impress everyone, right? So do Kaggle. That's a great source of projects. People do critique Kaggle a lot. So it doesn't teach you a lot of things, but it does teach you this core kind of modeling and feature engineering, this kind of thing. And then, of course, like, you can also do other projects. Let's say you see that a company needs to, like, one of the requirements is AWS, I don't know, SageMaker or whatever, just some technology, right? So what you can do is you can just allocate 10 hours of your time and think, what is the smallest project you can do with this technology? And just go and do this, and then do a write-up. And then you have your thing in your portfolio and something that you can talk about. I think this is also good to have, even though it's not an end-to-end thing. Well, maybe it's an end-to-end thing, but a small one. But again, you do this for, 3, 4, 5 things. And then all of a sudden you can talk about many different technologies. And then you have this background that you picked on Kaggle. And if you have 10, like a bunch of projects, like 10 projects like that, then I don't think anyone would not want to hire you.
So speaking of hiring, if there's any hiring managers listening in to this, or people that are in a role as a team lead, as a data scientist somewhere, what would you say that is the argument for bringing on a software developer to a data science team when you're serious about creating production ML, slapping the job title ML engineer on them and saying, hey, you've done a couple of things. You understand the basics of supervised and unsupervised learning. You maybe done a deep learning project. How do you find that communicates to the value of bringing, say, an experienced, say, Java software developer onto an ML team, helping them write better code? Like, what do you see that is a benefit?
I mean, like, let's say if the team doesn't have an ML engineer yet, right? Or like maybe there's a bunch of data scientists. What you can do is just show the number of incidents the team had, like in production, and show, okay, like, imagine if there was a good software engineer who would teach all these data scientists good engineering practices. And I think it's a good argument. Like, it's not that difficult to convince, because data scientists realize that they are not the best engineers, and that it's not their job to be great engineers, to be perfect software engineers, right? They need to write some code. But it's nice to have somebody who can actually show them, to to teach them best practices, to actually not just teach, but show how to do this and make sure that these practices are followed. Like I'm talking about things like having a CI/CD pipeline, having tests, like these standard software engineering stuff that, every software engineer knows. But when it comes to data science, very few data scientists follow that. And the core thing here, I guess, like the core argument, if that person, a software engineer, already knows some machine learning, so that person can talk to data scientists in the same, like they speak the same language basically, so they understand each other. And
no, I think that's a great angle for somebody who's on the outside. You're not, you're saying to kind of play up the overall engineering skills, software engineering skills, saying, okay, I've only got these couple projects, personal projects in ML, but here's what I bring to the table with regard to my other experience or training, as far as, general engineering skills. That's an interesting angle to add to the mix.
Yeah, maybe I can tell. So the first job in data science I got, it was a job as a data scientist. My official title was data scientist. But I suspect that the only reason I was hired is because I knew Java and I knew some machine learning, right? And the team, they really struggled with Java, right? So the way it worked is the data scientist would develop something in R or Python, but back then it was, a lot of R code. And then they would give it to engineering team saying, hey, like we have this awesome product, like everyone loves it. Let's implement this. And then when a Java developer from the other floor looks at this R code that is, just a zip archive that you sent over email. I'm just speculating. I don't know if this thing actually happened, but like I know that, it was a bunch of R code. It was very difficult to productionize, and the entire engineering team spent ages trying to replicate it. And I think they just understood that they needed somebody with Java background who would be able to kind of relate with talk the same language with the Java engineers, and maybe just do git clone their project and integrate already the data science solution there. I suspect that is the only reason I was hired, because I knew Java and I seem to be not completely useless when it comes to machine learning. So I knew a couple of things. And I think that is the reason they were interested in me.
That's interesting. It's not so much switching to machine learning as almost like Trojan horsing your way in with your other skills and getting a foothold and then expanding the machine learning aspect.
That's a good way of putting this. And actually, Charles mentioned at the beginning that there is a video on my channel about that. So that in that video, I did the interview. I interviewed Santiago. Maybe you know Santiago. He has a lot of followers on Twitter. Anyways, so he also has he also has this background, and the way he put it, I really like it. So the way he put it is, you don't switch as a software engineer. You don't switch to machine learning. You add machine learning to your portfolio. Mm-hmm. So you still stay software engineer. You just add another tool in your tool set. And I really like this metaphor. This is how you should think about, if you want to start doing machine learning, you don't switch. You just learn and use your existing skills to do machine learning, right? So you don't switch completely. You don't start from scratch.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
Yeah, at previous jobs that I've had, that's actually how I learned how to develop, was by either requesting resources or directly just telling management, like, hey, I'm taking this person for the next 2 years, get over it. Because they're really good at, Scala or Java or whatever language we were writing our code in. And I just paired with them and learned as much as I could, but also taught them. So we were both growing at the same time, me learning more about software development, they learning more about ML. And that's something that I recommend to my clients today when they're like, hey, we're struggling to get ML in production. We we have these issues that come up during crafting this particular project solution, and we don't want to hire consultants for every little thing. So what should I do? And I tell them the same thing every time. I'm like, just get a good developer. You don't need your best developer at your company because they're busy doing other stuff, keeping the lights on. But get somebody who has a lot of potential and promise and who is passionate, that is personable and can work with this team. And you just look for somebody who's hungry, who wants to grow, and then embed them in the team and watch magic happen.
Yeah, I think that's important too, because I've been trying to keep this comment back because it's not very nice. But I've worked with some software developers that don't follow best practices, right? That don't do things right. They just at the end of the day, work, ship it, right? And then somebody else has the maintenance nightmare later on. And yeah, I love the way you put it, because that developer that's hungry, that wants to learn, that wants to grow, that wants to do more. Those are usually the people that are out there learning how to write code that's maintainable, learning how to write code that will deploy well, that will stand up to some abuse, some things that they didn't foresee, that's going to do what you need it to do, and will work well with things that they don't 100% understand.
Yeah, I think it's really important as well with professions that focus on highly technical skills. Data science and software developers is something that I try to do continually wherever I go, in whatever group I work in whatever company, is always try to find somebody who knows more than you do, who is willing to both learn and teach, and then have that person be your challenger at all times. And it's just so happened that over the last dozen or so years in my career, that person has always been a developer. It's been different developers, but it's always been somebody that can be like, hey, I've looked at your code and there's this unstated elegance about it. Can you please just teach me how to do what it is that you do? I even do it today. I have a couple of people at Databricks in the field that it's just like playing jazz, like improv jazz with people. When you start talking through a problem, you're challenging one another. And because you're coming from these different backgrounds, come from a pure engineering background, like pure sciences engineering background, and then people that are coming from computer science background, we think about problems in different ways, and that complements one another. So I always see it as a success when somebody does exactly what you did, Alexey. Just like, hey, you come from this developer background, and you're coming into this field and sharing so much knowledge about best practices and how to do this, while at the same time you're growing as well. It's just awesome.
It's also, I guess I should shout out to the hiring manager back then at Searchmetrics, who I think he needed to push that to, I don't know, like first of all, he understood what kind of person the team needs, and then hire that person, but then also maybe convince others like that this is the kind of profile the team needs. So the team doesn't need another PhD, right? The team maybe needs an engineer. So that's also good that there are people like that in the industry now. And now there are more and more of them that understand that it's not at the end, it's not just about formulas and math. It's also about, being able to duct tape a bunch of open source libraries in a way that it doesn't fall apart, and then hide it so nobody sees it. And it looks nice. I think it's also an art, right? To be able to do that. And we need people like that now a lot, because that's those who actually deliver things to production. Like, it's engineering, right? So using these all open source tools and knowing their limitations and things like this. This is not something we learn at school when we study machine learning, right? You only learn this by doing, by practicing, by trying things. And yeah, that's where, at least this is how I see it. This is where the industry is now. And I think it's now easier than ever for software engineers to enter the industry. Yeah, maybe in the future it will change. I think now I see the trend of these no-code tools or low-code tools, maybe tools that democratize AI, democratize machine learning. I hope to see more tools like that make it a lot easier for people without a lot of engineering skills to also use machine learning. But so far, I think in the industry, industry really favors software engineers with some basic ML skills because they need to do a lot of stuff. And yeah, so I think it's a good time.
I think it really depends when we're talking about production ML, how many developers you would need to mix into the group based on what your company is actually doing and what that use case is. So there's a massive difference between doing a cron scheduled, let's say, XGBoost model or random forest model. You have your training data, you create your model, you're validating it, you're just scheduling that to run at 2:17 a.m. every day. There's not a lot of complexity in the architecture and engineering implementation of that. Even if you do full unit tests, you have an integration test, you're doing statistical validation, you're doing attribution modeling on top of all of that, you even have A/B testing with cohort determination for that batch prediction. Most data science teams can handle that with the assistance of a data engineer or somebody who used to be a developer. But that all changes when you're now saying, hey, we're an e-commerce site. We have a REST API. We need to support burst traffic of 450,000 requests a minute. And if the front-end development team is like, hey, we're busy doing stuff on the app. We don't have time to support this infrastructure. What do you see as the need for that next level of production ML? When you go from that small, simple batch stuff where you're writing to an LTP table all the way to large scale, how does that shift the team dynamic and makeup?
You just throw in a lot more engineers, I guess, and then... But I don't know if there is a simple answer to that. But I think the more... maybe if you're a startup, the proportion between data scientists and engineers can be 1-to-1. But the more mature the company becomes, the fewer data scientists you need and the more engineers you need, right? And I think, when I think about OLX, for example, the company where I work now, we don't have that many data scientists. So most of our, we call it product and tech organization, like all this R&D that is not support. I think 90% are developers. And probably every company is like that, right? If we're not talking about a startup. So we need, usually we need a lot more developers and people who know, all these Kubernetes things or whatever, things that can handle these spikes of traffic, right? Data scientists don't know that stuff usually. So you need to have somebody who knows that. And you just get them from other team, or if they're busy, I guess you'll need to hire them and you put them together and you work for a couple of years till it's there. Yeah, sorry. I don't know if that was the answer you were looking forward.
So what do you think was more trivial to learn? Was it applications of data science models for solving problems or just writing ETL? A lot of data science work that you do, particularly the more senior that you are, is sometimes a lot of ETL work and data transformations and feature engineering. So what was more natural to lean into for you?
Yeah, well, for me, it was if it's code, then it's easier, right? And all these ETL jobs is code. I wouldn't say trivial. I don't know, trivial. Maybe if you look at each individual piece separately, then it's trivial. But when you put everything together and you look back and see, wow, I did so many things, then it's not really trivial. But yeah, everything, a lot of work in data science. Okay, I would say maybe 90% of work is engineering work. And for engineers, they maybe what they need to do is become comfortable with speaking this language. They need to understand, okay, what is cross-validation? And if they see a formula, they shouldn't get scared. It takes some time, but yeah, I guess coding is natural, and all these ETL things, all this, deploying stuff or connecting different, you use scikit-learn, you need to connect it somewhere, you need to schedule it to run on the cloud. All this is engineering work. And it was somewhat easy, but also it took a lot of trials and errors to know how to do this right.
What about project development? When you're talking about, you walk into a data science team that's comprised entirely of PhDs, of traditional data scientists. As a first developer walking in there, you see them approaching project work as, well, we're going to work on this, we're going to experiment, and you see no artifact for 6 months. You just see a bunch of notebooks with a bunch of things that people are testing and commented out code, print line statements everywhere. And how do you shift a team that's doing that waterfall style, sort of post-grad research style work into Agile, into Scrum?
Yeah. So when you were saying that, this is exactly the metaphor I was thinking about, like waterfall. Exactly. So data science, I think like 6-7 years ago, at least in Europe, in Berlin, it was in this waterfall mode most of the time, right? So the companies would have a separate data science department that would produce notebooks, and then the management would get excited, and then these notebooks would go to the engineering team, and then engineering team would struggle for half a year to productionize it. And things shift now to more product teams. And I think this is how you should approach it, is you try to, instead of putting everyone like in silos, I think this is the term you, Ben, used in our previous conversation. Like we should try to break these silos, right? We shouldn't have a separate data science team that just does the magic, produce something that is very hard to integrate. You try to put everyone together. So you take a software engineer, you take an analyst, you take a front-end engineer, and you form a sort of a task force. So let's say for a next project that you want to do that involves data science, just take somebody from your data science team, like maybe one data scientist or two, take a couple of engineers from your engineering team, take a product manager. That's very important because somebody needs to, make sure that these people are not just having fun, but actually solve real problems. Because engineers have problems with that, right? So engineers like to have fun and it's difficult. I know for me, it's difficult to think of a user first instead of, there's this new shiny framework. So you need to have a product manager.
Hey, I resemble that comment.
Yeah.
Squirrel.
So, yeah, you put everyone together and in the same room, and you start thinking, okay, how do we approach this problem? So from the very beginning, right? So if it's a greenfield project, then you collect this, like you get together a task force, you put everyone in one room and you start brainstorming. And then, so what you need to have at the end is everyone is working on the same problem. It's not like first the data science team develops something, then they throw it over a wall to engineering. No, it's like a data scientist together with an engineer write production code from the very beginning.
It's like vertical integration of knowledge.
Yeah. Well, maybe production code from the beginning is too strong requirement, but at least like have everyone involved in experimenting and then productionizing this experiment. Put everyone on the same stand-up, right? So you know what engineers are doing, you know what kind of problems they have. Engineers know what kind of problems data scientists have. And I've seen that work pretty well in companies that had siloed teams. And I think this is a really great way to start. And then you form more and more task forces. And then eventually you don't have this central data science team anymore. And then everyone works in a cross-functional pack, so to say. And it's really great. And then at some point, I also saw that eventually what happens is a company is working in this functional teams, right? And then suddenly there is again a central team appearing that you see that these teams tend to repeat things. And then maybe there is a central team again that tries to be the common denominator and try to take care of all this repeated stuff. This is where, by the way, OLX is. So now we have all these cross-functional teams and we have a central team that kind of helps with the platform. So in a way, I hope we're not back to waterfall, but let's see how it goes.
Yeah, I can't state enough just how successful that paradigm can be at companies. I've lived through it, where some of my early projects, which were done in silos and kind of in this dank basement in the company where they're like, oh, all the nerds are down there. But once working in a company that takes ML seriously, you start working with this cross-functional group. At first, you don't even realize who you're going to learn things from or some of their insights, how that's going to inform how you approach ML in general. Some of the most clever things that I've learned about how to create like final payloads for supervised learning predictions have come from front-end developers, JavaScript people. They're like, hey, you shouldn't create a payload like that because it'll be more efficient for me to do a traversal through this collection if you create it in this way. I'm like, oh, I didn't even think of that. So I should just generate more of these, these elements so that you don't ever have an empty pane on your app. So that close working relationship is just invaluable for project work, I think.
Yeah. Otherwise, if it's different teams, then your communication is at best Jira tickets. Like, hey, let's make payload look like that, and then maybe you pick up this ticket in 2 weeks. But if people are on the same team, then this front-end engineer would just come to you, right, and say, hey, like, I don't like the way you send payload now because it's difficult for me. Can you quickly change it? And then you at the same time, like when you just go and change it, right? Because it doesn't take a lot of time for you to do this. And yeah, this is really great. I'm really a big fan of cross-functional teams.
Yep. I'm going to push this to picks because we're under some time constraints, but I think this has been a really positive conversation. Alexey, if people want to reach out to you and ask you more questions or follow what you're working on, how do they find you?
So the best way is to join Data Talks Club, which is an awesome community of data people. And I'm sticking around there. Actually, because I'm sort of an admin of that Slack, every time somebody joins using my invite link, I get a notification. So I will see somebody is joining. So feel free to ping me there. And yeah, so don't forget to say hi in the welcome channel. And yeah, just write me there. There are more, I would say, traditional channels. You can find me on LinkedIn. Just put my name and you'll find me. Then I'm also on Twitter. Is Al_Grigor. Because like I created my Twitter account relatively recently, so all the good names were taken. So I had to put some nonsense that very difficult to say. Yeah, but I guess if you just go to Google, put my name on Twitter, you'll find me. Yeah, that's probably Data Talks Club, then LinkedIn and Twitter are the best ways to reach out to me.
All right, good deal. Well, let's go ahead and do some picks real quick.
Hey, folks, I don't know if you've noticed, but I've been working a lot on figuring out how to help people become the most valuable developers on their teams or becoming the top 5% of developers in the field. If you're looking to level up, figure out how to contribute more, get the career you want, get the career that you want that will support the lifestyle you want, then you should check out the Most Valuable Dev Summit. I've invited some of my friends across the community, people that you've heard of, people that have worked on systems that you use on a daily basis, people who have invented new ways of doing things over the years in programming, and I've asked them one question, and that question is, how do you become a top 5% developer? How do you become 1 in 20 of the best developers out there? And so we're going to go ahead and have that conversation with them in interviews on the Most Valuable Dev Summit. And you can find that at summit.mostvaluable.dev.
Francois, do you want to start us off?
Sure. Mine's a bit of a soft pick, but it just after I'd been coding in the quiet for maybe the past 10, 15 years, and I've rediscovered ambiances. You can pretty much code to anything. You can, as far as audio, right? So I discovered I can go to YouTube and just type ambience, whatever, and it's a really nice. Maybe it was because of the pandemic, you feel more alone. But there's things like coffee shop ambience, space station, underwater station. Any type of music. Jazz, whatever, is just something that I forgotten existed somehow, and I stumbled upon it, and it's really nice. There's a cliche of being at the beach, whatever, but there's pretty much everything, and it's kind of nice. Gives some variety from working from home all the time and the same kind of setting. You just cut out everything, and you can pretty much be anywhere, whatever. There's some really interesting ones where there's a coffee shop and you can actually overhear conversations. There's a few comments on the video that say, this is probably illegal. But yeah, the person, you're in some college coffee shop and there's crazy conversations about projectile vomit and things like that. It's just really funny. But yeah, that one's a bit distracting. But yeah, just general ambiences, if you're looking to spice up a bit or, bit of change of pace from the ambience you're working from, that's kind of nice.
Yeah, I'd agree. Projectile vomit is a bit distracting in general.
Ben, what are your picks?
My pick is pretty relevant, actually, to today's discussion. Coming into this, I didn't even know we were going to be talking about this topic, but I've been doing a lot of mentoring recently, and specifically mentoring of people that come from a data engineering background. And they want to know, learn ML. They want to be able to apply machine learning. They don't really need to know the theory behind algorithms, which is how most data scientists learn it when you're coming straight out of school, or mathematicians would learn it. But I've been using our guest's book to actually do some of that teaching because of the way that Alexey approaches instruction in Machine Learning Bootcamp, which is a Manning book that he's written. I've been going through it and kind of seeing that perspective of how to communicate, getting started from a developer/data engineer's perspective. And I got to tell you, Alexey, it's actually shortening my mentoring time down by at least 80%, because I have all these examples that I can use to show somebody. Don't worry, they're going to get a copy of the book as well. But it's just helping me read through that and see a different teaching style than what I typically do with people. And it works. So it's a great book.
Yeah, maybe I would like to add to that my book is about to go out to be published. And what I want to do is I want to do a free course, online course, based on the book starting in September. So you can already register. And yeah, if you're the kind of person who needs to, have a schedule to learn something, to have a course, then the course starts in September. It's called Machine Learning Zoom Camp. I thought that it's since there is book camp, then maybe a Zoom camp is also a thing. So yeah, check it out. I don't know. I don't think Google actually, like if you put Machine Learning Zoom Camp in Google, it will try to correct you to Machine Learning Boot Camp or something, Boot Camp. But yeah, so you'll find it also in Data Talks Club. I don't know if it qualifies as a pick, but yeah. Thanks, Ben.
Yeah, we did a quote unquote book camp for JavaScript last year. And it was based on some books that Kyle Simpson had written about JavaScript. So I saw that and I kind of smiled to myself because I love the term. So anyway, I'm going to throw in some picks real quick. One is, I think I mentioned this in the last episode, but I'm doing these Q&A/training sessions every week. So if you're looking for ways to kind of make your career go to the next level, you can do that. Just go to devchat.tv/level-up and you can get in on all of the good stuff there. It's like 10 minutes of some kind of training, and then we'll just answer questions, do some coaching until you get all your questions answered. So yeah, that's pretty much it. Alexey, do you have some picks for us?
Yes, actually, I was thinking, what should I pick? And recently, Ben and I had a conversation. So that time it was different. So I was interviewing Ben, and the interview was really great. So we talked about, it's called Running from Complexity. And our conversation was about like, how do we make sure that our projects are successful by making them simple first? We don't complicate, we don't start with complex things, and we start with simple things and evolve. And we talk a lot about like a bunch of things. Some of these things we talked today, like about siloed team. We talk about things like also the IKEA effect is like when you get attached to things you build. It's a really great episode. I really enjoyed talking to Ben. So that's my pick. So check out our chat with Ben. And yeah, it's again, if you go to Data Talks Club, there is a section with podcasts, and the episode I'm talking about is called Running from Complexity. I'll share a link. So it's really like if you're thinking how you should spend 1 hour of your life and you're not sure how exactly, that's like probably the best way to do this. And it's a great, thanks, Ben, for the chat. It was really great.
Oh, thanks, man. That was fun.
All right, folks, we're going to go ahead and wrap up here. Thanks again, Alexey, for coming, and thanks to our panelists. And until next time, folks, max out.
Take it easy.
Have a good one.
Goodbye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.